Now let's draw some vector fields. The vector field that is defined by these two functions here, and that actually gets integrated in this example. Yeah. So for this, first of all, the vector field will only be sampled on a grid of points for which we need a start and stop values in x, start and stop values in y, and a grid size delta x. And I will just do the lazy thing by saying there will be a max value for x. Let's say 5. There will be a max value for y. And then let's be lazy. Let's just take the opposites. Whoop, voila. Nope. Yeah, it's a bit tricky with with a space. You can actually type in max, and y min is y. Now the x will be, I don't know, 0.1, and he has already offered a slider, and for the slider it actually makes sense to that it only starts at 0, and we will go up to, I don't know, 1, and the step will be quite small. But actually the x will be something that we will only set in the background, or maybe offer an input box, not a slider, because animating that would be way too costly and doesn't really add anything to the understanding. Same thing goes for the scale S that I've already set up here, which will help us set the scale for drawing the vectors. And the scale rarely exceeds 1. Yeah, something like that. Now we are ready to draw our vectors. So this will be a sequence of sequences. Now let's first already set the variable on the outer loop, so to speak, and I call it uppercase y, because sometimes lowercase x and y have special meaning in GeoGebra, and that interferes here, and I want this to go from y min to y max in steps of dx. Actually, dx is the same as dy here. And I want the variable, the inner variable, to run from x min to x max in steps of dx. And now what do I want to sequence over? Well, vectors. And the vector will take a start point and an end point, like that. And the start point will be uppercase x, uppercase y. And the end point will have added something to it, which will, in this case for the x coordinate, be s times v1 of x and y with a comma. And here this will be s times v2 of x and y. Yeah, sometimes you have to type a bit blindly, and then stuff like that happens. v2, arrow key, x and y. Okay, if everything went fine, then we should see our vector field. Whoa. Yeah, well, it's a bit hard to see. It goes from -5 to 5. Yes, but dx is actually way too big, way too small. So this will be 50 by 50, 2,500 arrows. No, let's set this to 0.5 maybe. And then if we reduce the scale, and you see already it's way too computational heavy to have a slider do that. Okay, now we start to see something. Yeah. Okay. Well, then let's put in some boxes for the x and s. So an input box for, well, let's call it delta x more properly and link it to dx. And let's make it white. Whoop, nope. Actually, no, not this one, but well, this one. Color would be white, and the size would be very small. We don't need much space for that. And then let's also have an input box for the scale. Let's call this just scale. S. 3. Color is white. Now, the vectors right now are drawn in green, but maybe let's use orange. And also let's make them a bit more transparent. I think that looks better. Yeah, the line opacity would be way reduced, maybe at 20%. And of course, I don't want to be able to select this. Especially with vector fields, this can be very annoying because they're all over the place. Right now, this triggers nothing. And okay, the scale, maybe 0.02. That looks good already. And if we zoom in, you don't even see the bounds of this. But actually, let's make it a bit more opaque. Yeah, like that. All right. So the last thing I want to introduce here is, you see now that the bounds, we have set them programmatically. And I have to go in here to change them. But wouldn't it be nice to have an actually draggable handle, like the size of a window, that allows us to adjust the size over which the vector field is sampled? And we can do that. We can just define a point, a free point. Where is it? B. Let's make it, can we make it a bit, yeah, it's a bit larger. And also I want to make it white. Very unassuming. And now all I have to do is to redefine x max and y max as x of b and y of b. Yeah, there you go. And as I change b, which is a bit computation heavy, but it works. And to make this point even more visible, that what this point does is it redefines the size of the window over which the vector field is sampled. We can actually define 3 more points here and then just draw dotted lines all around the whole thing. So I can just define a segment from B to, well, x of b minus y of b. And right now we don't see it. Now you see it. Then I have another segment from x of b minus y of b to minus x of b minus y of b. And that will also be gray. And then we have a segment from minus x of b minus y of b to, I could also use x max or x min or something like that, minus x of b y of b. And then we need a segment from minus x of b y of b back to b. and these two will be somewhat gray. And let's select all of them and also change the style, make it a bit more dotted. And then also this point makes more sense as in gray. Okay. And now you see that we can resize the window over which the vector field is sampled. All right. We can close the algebra view. And then if also something with these UI elements, positioning them can be a bit, well, not tricky, but it's good to know a bit, to see how it's being done. Because right now, these things are fixed, but you already see that they are not perfectly aligned. And so we have these two options: to lock the object and to pin it to the screen. Now, if I disable lock the object, I can actually click on it, well, practically this part here, and move it around and really position it pixel perfect. Same thing here. And then lock them again. And this is the same thing, but let me show you what I do, what happens if I don't pin it to the screen. Then if I zoom, you see that it actually follows the geometric coordinates. It takes the geometric coordinates of where it actually is right now, which is about -10 and 5, and tries to stay there as much as it can. So this is good for having elements follow geometric objects as we zoom in and out. But actually we don't want this. We want this position to be defined by the pixels in the window. And yeah, maybe it should also go up a little bit more. It's not locked. Okay, there you go. Let's lock it. Now the example, we also want this to be more somewhat here. And the slider also makes more sense to have it next to this example button. Let's lock it. And these things also are really peripheral. And maybe it makes most sense to have them down here at the bottom, where they don't take too much of the visual size, of the visual attention. All right. I think this applet is just about presentable and ready for uploading.